Welcome everyone. We have a motion problem here and it reads, a car starts moving from rest and accelerates uniformly at 3 meters per second squared for 8 seconds. It then travels with a constant speed for some time before coming to rest with a uniform retardation of 2 meters per second squared. The total distance traveled by the car is 720 meters. Question 1 reads, draw a velocity time graph to illustrate the motion. Question 2 reads, calculate the total time taken for the journey. Question 3 reads, calculate the average speed traveled by the car. So if we analyze this problem, the body starts moving from rest. It accelerates uniformly at 3 meters per second squared for 8 seconds. So it accelerated to attain a particular velocity or speed. So it then maintains that speed for some time, which is not given. We don't know the time during traveling at a constant speed before coming to rest with a uniform deceleration of 2 meters per second squared. So in summary, after moving from rest, it accelerated, then maintained a uniform velocity, and then retardates to rest. That is the general idea that we can take from this problem. And the total distance traveled here is 720 meters. So if we should just move on to sketch or draw the velocity time graph, we'll have velocity in meters per second represented on the y-axis. Then we will have time represented on the x-axis. That is time in seconds. So let's indicate the starting point 0, the origin. For this motion, the body starts moving from rest and then accelerates at 3 meters per second squared. So we're going to represent that like an upstroke. The body accelerated at 3 meters per second squared. The duration for the acceleration was 8 seconds. So that is 8 seconds here. We can call that T1 since it is the first time for the motion. The body starts moving from rest. It accelerates at 3 meters per second squared for a duration of 8 seconds. That is from this point to this point is 8 seconds to attain a steady speed. So this is the point where it attains a steady speed. It maintains that steady speed for some time. We don't know how long it lasted. So we can just represent it like this. So the duration, while it maintained a constant speed, is not known. But we can call that T2. That is the time for the second event. And finally, the car decelerated to rest. But the duration for that is also not known. So the time there can be indicated as T3. This is how the velocity time graph is going to look for this event. We have a body that starts moving from rest and accelerates at 3 meters per second squared for a duration of 8 seconds. Then it maintains a constant speed for a particular period, T2, which we don't know. It then decelerates to rest for a particular duration, which we represent as T3. But the deceleration or the retardation was at 2 meters per second squared. So that will be a negative because we know that deceleration is a negative acceleration. For this velocity time graph, what we need to know is the final velocity attained here. We can call it V1 if we want, since from rest it is the velocity that has been attained for the first event. Moving on, if we should analyze this diagram, we realize that we have the shape of a trapezium. So the total distance traveled is the area under the curve here, which is the area of a trapezium. Now, if we analyze from this point to this point, the duration is 8 seconds, but we don't know T2. So, but what can we say the duration from this point, that is from the origin to this point, it will be 8 seconds plus T2, right? So we can indicate that as T2 plus 8 seconds as the time at this point. We also don't know the time T3 taken during retardation. But what we know is for the time taken to reach at this point from the origin will be T1 plus T2 plus T3, or we can say T2 plus 8 seconds plus T3. Okay, so the time here at this point, that is the time taken from the origin way down to this point, will be T2 plus 8 seconds plus T3. So we can say let the total time taken for the journey be T. So which means T, the total time, will be T1 plus T2 plus T3, or alternatively it can be T is equal to T2 plus 8 seconds plus T3. It's the same thing. T2 is from here to here, which will also be the same as from this point to this point, if we should consider them as two parallel sides. So we can say this side is T2. So if I want to find V1, I can say using V is equal to U plus AT, then V1 is equal to U1 plus A1 T1. So remember, we have separated these diagrams into 3 events. This is the first event, this is the second event, this is the third event, okay? Now V1, which is the final velocity at the end of the first event, is calculatable using V is equal to U plus AT. So we can say V1 is equals to the U1, the initial velocity for the first event, plus the acceleration for the first event multiplied by the time for the first event. If we do that, we can have V1 is equal to U1, which is the initial velocity. It started from rest, so it will be 0, plus the acceleration is 3 multiplied by the time is 8. So we'll have V1 is equal to 24 meters per second. So that is the final velocity attained at the end of the first event. Therefore, we can indicate V1 as 24 meters per second on our velocity time graph. So V1 is 24 meters per second. All right. So considering this diagram, if we know V1 as 24 meters per second. And since the object maintained that velocity before it decelerates to rest, it means the initial velocity at this point for the third event will also be 24 meters per second. So if we have that, then we can also be able to know the time here, t3. So let's go and calculate t3. It is now calculatable. Now, using V is equal to U plus AT, we can say V3 is equal to U3 plus A3 T3. In that case, we can say V3 minus U3 is equal to A3 T3. But since I wanted to find T3, I will divide both sides by A3, both sides by A3. So therefore, T3 is equal to V3 minus U3 all over A3. So T3 is equal to V3 is 0 meters per second since the body comes to rest. So it means the final velocity will be 0. Then minus U3 will be 24 meters per second since it is the velocity at which the body starts to retardate to rest. Then divide this by the acceleration is negative 2 meters per second squared since it is a deceleration. Therefore, T3 is equal to negative 24 divided by negative 2. T3 is equal to 12 seconds. So T3 is now known. Moving on, if we consider this trapezium, this point to this point will be side A. Okay? And this point to this point will be side B. And the height of the trapezium will be here. So which means A is the same as T2, B is the same as T1 plus T2 plus T3, or simply T2 plus 8 seconds plus T3. And the height will also be the V1, or the final velocity attained during the end of the first interval. So it's going to be 24. So using this information, we know that the total distance traveled by the car is going to be area under the graph. So the area under the graph gives a shape of a trapezium. Therefore, we have to use the area of a trapezium. The area of a trapezium, S, is equal to half into A plus B H. So therefore, S is equal to half into A is T2 plus B is T2 plus 8 seconds plus T3 multiplied by the H is 24. Okay, so because we already know the distance given as 720, I will just move on to replace it directly. So distance is 720. Therefore, we have 720 is equal to half into T2 plus 8 plus, we have calculated T3 as 12. Multiply this by 24. 720 is equal to 2 here into 24 will be 12. So 2 goes once, here is 12. Then we'll have T2 plus 8 plus 12 is 20. Then multiply this by 12. So what I can do next, I can divide both sides by 12, both sides by 12. to have 720 divided by 12 as 60 is equal to T2 plus T2 plus 20. So 60 is equal to T2 plus T2 is 2T2, then plus 20. Collecting like terms, I will have 60 minus 20 is equal to 2T2. That is 40 is equal to 2T2. So to find T2, I'll divide both sides by 2. In that case, T2 is equal to 20 seconds. Okay? So which means T2 is 20 seconds. So that is 20 seconds here. And T3 is calculated as 12 seconds. T1 is known as 8 seconds. Therefore, we can be able to calculate the total time taken. We've said that both T is equal to T1 plus T2 plus T3. So what is T1 is 8 seconds. What is T2 is 20 seconds, and T3 is calculated as 12 seconds. When we sum all that, we'll have 40 seconds. So which means for question 2, the total time taken by the car is 40 seconds. Moving on to the third question, which is the average speed. We know that it is equal to total distance traveled divided by the total time taken. So the total distance traveled was 720. The total time taken was 40. In that case, the average speed will be 18 meters per second. That is all for today. Thank you very much for watching the video. If this is the first time visiting our channel, please subscribe, like, and share the video.